Today's video is going to cover the addition and the subtraction properties of equality. This is lesson 1.2, and these are two separate properties that we use all the time. We use the addition property all the time, and we use, that's the subtraction property all the time. So I'll go very slowly as we go through this concept slide. This is this slide that you're getting down in your notes. The additive property of equality, or the addition property of equality, and the subtraction property of equality, you have been taught are inverse operations. So this is what you're using when you use inverse operations. These are rules in math that allow you to manipulate equations so that you can solve for the variable that you want to solve for. So let's go ahead and define what they mean in words. So the addition property of equality, or we can just say APE, is adding the same number to each side of the equation results in a new equation with the same solution. So when we add a number to both sides of an equation, what we get is another equation that is the exact same, except it's written in a new way. The subtraction property of equality is the same exact as the addition property of equality, except instead of adding the same number to each side, you're subtracting the same number to each side. So these are similar properties, except one deals with adding and one deals with subtracting. So you can look over here. Here's the algebra definition, and this is what they give you. They give you an equation, x minus a, and they always use letters, x minus a equals b. So if we have x minus a equals b, and we're trying to solve for x, we've got to eliminate this minus a. Well, what's the inverse of subtraction? Well, the inverse of subtraction is addition. And what do we want to eliminate? We want to eliminate a. So we can say that x minus a equals b, this equation right here, is the same as x minus a plus a equals b plus a. And the reason why these are the same, or have the same solution, is what they did to both sides of the equation was they added the same exact letter. And if you add the same exact letter to both sides of the equation, you have not changed the solution, and that is a rule that you can use at all times. Down here we have the same exact thing, except they're not adding the same letter to both sides. In order to get x by itself, you got to do the inverse of addition, which is subtraction. And they're subtracting the same letter to both sides. So we can say that this equation right here is equal to this equation right here, because they have the same solution. What they're doing to this side and what they're doing to this side is the exact same, so the equation has not changed its solution. Now, as we go through this example, what we're going to do is we're going to solve like we know how to solve, but we're going to give a justification for what we're doing when we're solving. So here we have the equation x plus 7 equals 4, and the justification here is it's given to us. We don't need to justify, it was given to us. So let's go ahead and move on to the next step, solving for x. What do we need to do to get x by itself? Well, we need to eliminate the plus 7, or the positive 7. Well, what's the inverse of a plus or a positive? That's a minus or negative. So we're going to subtract to undo the addition, and the number that we want to eliminate is 7, so we're going to subtract 7. Well, if we subtract 7 from the left side of the equation, we have to make sure that we subtract 7 from the right side. And you can write it horizontal like this, or you can write it vertical. And what's the justification, or what allows us to subtract 7 from one side and the other side? Well, we just learned that. It's SPE. It's the subtraction property of equality. So in this box, I'm just going to write S, P, E. Just like that. Now, how do I go from this equation to this equation? Well, x plus 7 minus 7, we know that plus 7 and minus 7 are opposite numbers. And we know that opposite numbers simplify to 0. So we've got x plus 0 is just x. And then if we simplify the right side, we've got 4 minus 7. And I don't know exactly what 4 minus 7 is off the top of my head, so I'm going to go ahead and use the calculator. Back here. 4 minus 7. negative 3. So I know that this is negative 3. Boom. So here's my answer. I've solved for x, but I've got to justify this last step. And if I had to justify how we went from here to here, well, what did we do? We simplified. So I can just say we simplified. So that's pretty much what we're doing today, is we're solving just like we know how to solve, but we're giving justifications as we do it. And here we have common mistakes that you might make, or you'll see several students have made in the past. One of the common mistakes is when you're solving for x here, a lot of students just subtract 7. They understand that the inverse of addition is subtraction, and they understand that they need to subtract 7, but they'll only do it to one side and they'll get x equals 4. But this is incorrect because they did not subtract 7 to both sides. If you subtract 7 here, you've got to make sure that you subtract it to both sides. So make sure you're doing it to both sides. The other mistake that students make is they do the same exact operation to both sides, which you can totally do. You can add 7 here and add 7 here. That is the additive property of equality. But adding 7 here and adding 7 here does not get x by itself. What you do, or what happens when you add 7 to the left side, is you get 14. Because 7 plus 7 is 14, and 4 plus 7 is 11. So you can add 7 to both sides, but that doesn't get you any closer to solving for x. Pause the screen if you need to copy the rest of this down. I'm going to go ahead and move on to practice example 1. Only 2 examples today, so I'm going to go ahead and write, we've got the equation, and we've got the justification. So as we solve this equation for x, I'm just going to justify it. The first thing is given to us, so I'm going to write g, and we're solving for x, so we need to get x by itself. So what do we need to eliminate? We need to eliminate this negative 12. Well, negative in front is the same thing as subtraction, and the inverse of a subtraction is addition, so we know that we need to add, and the number that we want to eliminate is 12. So we're going to add 12 to one side. We've got to make sure that we add 12 to the other side. What allows us to add 12 to both sides? The additive property of equality, and we're going to abbreviate that with APE, or APE. That's an easy way to remember it, APE. When we add 12 to both sides, we simplify the left side, and we've got negative 12 plus 12. These are opposite numbers. We know the opposite numbers simplify to 0, and we're left with just x, which is what we wanted, equals 1 plus 12 is 13. So we've got x equals 13. Here's our new equation, and this is our final equation because we've got x by itself. How did we get from here to here? We simplified. So I can just write simp. Last example, here we're solving for x again. We've got the equation and the justification. This was given to us. If we're solving for x here, we need to eliminate this 14. Since the 14 is a positive 14, we know that the inverse of a plus is a minus or subtraction, so we're going to subtract, and the number that we want to subtract is 14. We make sure we do it to both sides. The justification here is what allows us to subtract a number to both sides, the subtraction property of equality, or SPE. After we get our new equation, which is 18 minus 14 equals 14 plus x minus 14, we can go ahead and simplify, which is our third. And what we get is 18 minus 14 is 4 equals 14 minus 14, that is 0, plus x is x. And this is our final equation because we've got x by itself. Good luck on the problem set. Make sure that you complete it at a level of mastery. That way you are ready to take the quiz.